Welcome back to this NFT course for beginners, where I'm going to teach you how you can create a full NFT collection using Solidity. First, we're going to create the smart contracts for the NFT collection using Solidity. Then we're going to upload our metadata for our NFTs on IPFS using Pinata, and then after all of that's done, we're going to deploy our NFT collection on the Polygon Mumbai testnet, and we're going to verify that the contract is deployed using this Polygon Scan blockchain explorer. And then we're going to even visualize our NFTs that we've deployed in our NFT collection using Opensea. First, we're going to create the folder for our NFT project by going inside desktop and just saying make directory, and we're going to call this Pokemon's NFT Collection. Then I'm going to move to this Pokemon folder by using cd, which stands for change directory. And then we're going to have to initialize an npm project by doing npm init-y, and y stands for just saying yes to all the questions. Then we will have to install Hardhat, and Hardhat is just an npm package. You can see more information on this npm.js website, but basically it's an Ethereum development environment that helps us more easily develop smart contracts and deploy them to blockchains. So we're going to go up here and say npm install, and then we're going to do save def hardhat. After we've successfully installed hardhat, let's just go ahead and say code and dot. This will open this project inside Visual Studio Code. And now we have successfully opened our projects, and I'm going to go here, click on new terminal, because we'll have to create our hardhat project by saying npx hardhat. And remember, this command must be in this project. And we're going to, you have a bunch of options here, but I'm going to create a basic sample project. And this is going to be the root, so I'll just press enter. We want to add git ignore, so press yes. And yes, we do want to install the dependencies. So to set up our project, what we're going to do is go up in this contracts folder and delete this example project because we're not going to use this. Move to trash. And then what we're going to do is, if you didn't know, an NFT should inherit from the ERC 721 standard. So to add this 721 standard, we're going to create a new file here and call this ERC 721.sol. .sol stands for Solidity. And I'm going to paste this code, which I'm going to provide you in the description. Basically, this is just a smart contract that represents the ERC 721 standard. And later, when we create our NFT collection smart contracts, we're going to inherit from this ERC 721. And other thing that we're going to do is just go inside scripts, and we're going to delete this, or actually rename this to deploy, because this is basically the script we're going to use to deploy our smart contract. And also I'm going to delete this test folder because we're not going to write any tests. So let's do a quick overview of this project. First, we have the contracts folder in which we implement our smart contracts. For now, we just have the ERC 721 standard, and I'm going to zoom in a little bit. Also, we have node modules. We have the standard npm stuff that comes with any npm project, like the package.json. We have a readme file. This is provided, and also the git ignore file and the readme file are provided by the Hardhat. And also we have this scripts folder in which we have only one JavaScript file, and this is what we're going to use to deploy our smart contracts. When we code up the smart contracts here, we're then going to just execute this file and deploy our smart contract to a test network. Also, the most important thing is this hardhat.config.js file. Here in this module .exports, we're going to set up our network. We're going to provide the network or the blockchain or the test network, I should say, to which we're going to deploy our smart contract. And finally, we've come to the most interesting part where we actually create the smart contract. And I'm going to create it by right-clicking on this contracts folder, new file, and then this is going to be a Pokemon NFT collection. So let's say Pokemons. That's all. We're going to write pragma Solidity, and we're going to provide the version, which is going to be anything above 0.8.2. And also we're going to define the contracts by saying contract, and then the name, which is Pokemons. And this contract, as I said, person needs to inherit from the ERC 721, and to inherit from some class, you need to say is. Actually, we don't have this file does not know about this file, the ERC 721, so we're going to import the ERC 721 by saying import, and then just inside this string we're going to, this dot is going to present the current directory we are, and then slash and the ERC 721.so. And here I'm going to, now I can inherit from the ERC 721 by saying is ERC 721. If you were to check out the ERC 721 standard, you will see on their official website, you'll see that you need to provide for, it's mandatory, it's necessary for each NFT to provide a name, symbol, and a token ID. So we're going to provide this by saying declaring a string, which is going to be public, and this is going to be the name of our NFT. And then we're going to provide a symbol for our NFT, and it's going to be of type string. And this is going to be again public. And also we're going to provide a uint 256, which is going to be public, and this we're going to call this token count. And this will act both as a count of our NFTs, how much NFTs we have minted, and also it will act as the token ID. And a token ID is just a number that uniquely identifies an NFT. So we're going to increment, this is going to start at 0, and we're going to increment this as we mint NFTs. So it's going to start off as 0, and then once one person mints an NFT, it's going to increase to 1, and this NFT will have the token ID of 1, then 2, 3, etc. Then we're going to add this constructor function, and this constructor is executed only once when the smart contract is deployed to the testnet. And this is going to take in two arguments, the name and the symbol. And we're going to provide the name and the symbol once we're going to deploy the smart contract. And we're going to say string name with an underscore, because we don't want to shout out this name variable. And also a string, you can either store a string inside memory or inside storage. And we're going to use memory because memory acts as the RAM, and memory storage is stores variables on the blockchain. And also we're going to have another string, which is going to be the symbol. And here we're going to just pass those variables to the state variables name and symbol we already have. The next thing we're going to do is create what is called a TokenURI function. And this is a very important function. It basically returns us a URL that points to the metadata of an NFT. So an example URL would be this one. So it let's say it returns this URL, which points to IPFS, and here you have the ID of the NFT. And if you were to load this on a website, you would see the NFT metadata like the image, the attributes, etc. So to create this function, I'm going to go down here and say function, and then TokenURI, and then this function is going to be public. It's also going to be of type view, so this is not going to make a transaction. We're only going to return a URL. So to return URL, let's just say it returns string, and this string is going to be stored in memory. And also this function takes up the, guess what it takes up? It takes up the token ID, which is the ID that uniquely identifies an NFT. So everything makes sense. The TokenURI takes in this token ID. Let's just write this down. U into 56 and its token ID. So it takes up this token ID and then it returns us the URL in which all the metadata for this NFT is stored. So we're going to now, actually we're going to store our token IDs, or URIs I should say, inside of a mapping, which we'll define here. Since we'll have a lot of NFTs, we need to store all of our token URIs. Since this is an NFT collection and we're going to mint a lot of NFTs in here, inside this collection. So we're going to define a mapping of uint to 56 to a string, like so, string. And this uint is going to represent the token ID, and this string is going to represent what this token URI function returns, which is the URL that points to the metadata. And this is going to be private, and we're going to call this token URIs. Save this, and then we're going to return here. Just say return, and we're going to go inside our mapping, inside the token URIs, and we're just going to access the token URI for this NFT that has this token ID we're getting passed here. And also there's another requirement. We're basically done, but there's another requirement, which is basically that we check if this address, if this token exists. And how do we do that? We have, if we go up here in the ERC20 and search for owners, we have this mapping, basically the owners of the NFT. And here what we can do is we can check for owners, and we can say token ID, and this is basically the we're going to see get the address of the owner of this NFT, and this needs to not be equal to 0, and we cannot compare this address to 0. We need to convert this 0 to an address, so we're going to say address and then pass the 0. And if this actually returns an error, we'll print out something like token does not exist. And we're going to save this, and we're done for the TokenURI function. And next thing we need to create is the mint function. So I'm going to write a mint function here, and this is the function that creates a new NFT inside this collection. And we're going to say function mint, and then this is going to be a public function, and this is going to take the token URI, and this token URI we're going to store it inside memory. Let's put an underscore here, and what we need to do is actually we need to do a couple of stuff, because when you actually mint NFT a lot of stuff happens. First of all, we need to add 1 to this token count, because now we're increasing the token count, and basically this is going to be 1 now. It starts from 0, it's going to be 1 with the first NFT you mint. And then what we need to do is, if you go inside this ERC 721 standard and search for balances, you're going to see this variable that represents the number of NFT a person has. So we're going to have to access this variable, and we're going to pass the message.sender, which is the person that triggered this function, the person that wants to mint this NFT, and we're going to increase balances by 1 once again, because this person now has minted and owns one additional NFT to the balances he had previously. And then we're going to again access this owners array, or mapping I should say, that we accessed here, and we're going to pass this token count, and we're going to say equal message.sender, and this basically means the owner of this NFT is this guy that triggered the function. This is again another mapping we should definitely update. And then we need to access the TokenURI and just add this is, if you forgot, this is just a mapping that we defined previously. So we're going to say the token count, say equal to the token URI that we're getting passed here. Also, another thing that we should do it, we should emit this transfer event that is defined in the ERC21, and you can see we need to pass it from which and to who, and the token ID. And since this is a mint event, we're going to say emit transfer. This is how you would emit a event. And for from, we're going to just pass address of 0. You have probably seen on Etherscan, whenever you mint an NFT, the from is an address like so, with a lot of zeros. This is basically what we're doing. And the owner is going to be the message.sender, and the token ID would be just the token count we have now. And before we jump to the most interesting part, where we add the metadata for our NFT, we just need to add this function, SupportsInterface. For this, basically is required by Opensea, so later we can visualize this NFT collection on Opensea. And now to the most interesting part, where we actually create the metadata for our NFT. So I'm going to create a new folder and call it metadata, and here I'm going to actually start by, I have these pictures of NFTs. You can add as much NFTs as you want here, as much as you want, as many pictures as you would like, but I'm going to just create one NFT in this NFT collection, and it's going to be this Pikachu. So I'm going to drag it here in the metadata, and actually we're going to create a new file and call it Pikachu.json. This is going to be a JSON file where you define all the attributes and provide a link to the hosted Pikachu image. So this is the format. I'm just going to paste it here, It's a very simple JSON format where you just have one object, which is a JSON object with this yellow curly brackets, and then you have a name as the key and value. This is going to be our name, which is Pikachu. You have description and your description, and you have an image in a key and a link to where this Pikachu is hosted. Currently we don't host this picture. That's what we're going to do next. And here in this XXX is actually the ID that our IPFS provides us, so we can get the link to our hosted image. And for those of you that didn't know, IPFS is just a decentralized way to store some images and data on the blockchain. And also you have attributes here, which are just the attributes that we have for this NFT. And this is an array, as you can see, of objects, and in each object you just define the trait type. I have power, balls, and magic here. You also define the value, how much power does this Pikachu have, which is 7 in this case, and the maximum he can have is 10. And it's the same for the other attributes. He has 8 balls, so no balls really, and he has 5 magic out of 10. So now we have the metadata, which is this JSON file, and we have the image. And we need to host this data on IPFS, and we're going to host them using a service called Pinata. So if you don't have an account here, you just need to create an account. Go up here and click on upload. We're going to upload first of all a file. Select the file, and I didn't say this, but let's go inside desktop first. Let's choose go inside our project, which is this one, and then just go inside the metadata folder, which is this one, and just choose Pikachu. We're going to upload the image first, and we're using Pinata because in IPFS, if you didn't know, IPFS makes clears out the garbage, and if no one interacts with your NFT collection, if no one buys NFTs, trades them, they get deleted from IPFS. And this is why we use Pinata, because Pinata prevents that from happening. And since now we have this Pikachu image hosted on IPFS, we're going to copy this content ID, which just uniquely identifies this image, and we're going to paste this in this paste.cid into this link in the Pikachu.json file. And this is basically, now we have the link to where our image is hosted. And the next thing is to, of course, upload this JSON file as well to the IPFS. And this JSON file is basically our NFT, because now, as you can see, we have all the data for our NFT. We have the name, the description, and we have an image and also the attributes. So now we can upload this by going into upload file, selecting a file, and just choose this JSON file. Click on upload, and we're done. So in the next step, we need to add the network or the testnet we're going to deploy our smart contract to in this Hardhat config file. And for us to do that, we're actually going to, let me just first tell you that we're going to deploy our smart contract to the Polygon test network called Mumbai. So first, actually, I'm going to change the Solidity version here in the Hardhat file to 0.8.2 because that's what we're using here in the smart contracts. So everything's is consistent. Then we're going to add networks, and this is going to be an object, and here I'm going to say Mumbai, and this is also going to be an object of the URL of this Mumbai. Let's just say Mumbai RPC, and this is basically just a URL that provides the metadata for the Mumbai testnet. And then we're going to have accounts, array of accounts that basically deploy the smart contracts. And here we need to provide a private key. So where are we going to get this Mumbai RPC and private key? Actually, first of all, we're not going to just paste the private key here because it's not safe. Usually you may use version control and upload this to GitHub. And to hide all of these private keys and the Mumbai RPC, we're going to use a package called .env, and we're going to install this package by doing npm install .env. So we have successfully installed .env, and we're going to require this .env by using require.env, and we're going to configure this. And here we're going to use process.env. Actually, let's just first create the env file, and we're going to create it by just saying new file and .env. And here we're going to add a variable, which is the Mumbai RPC. We're going to say equal, and then here we're going to define later the Mumbai RPC, and we're going to provide the private key of the account that's going to deploy the smart contract. And we're going to just do a placeholder here. And here, how can we access those variables in the config file? Is just through this process.env the name of the variable, which is the Mumbai RPC. That's how we have defined it in the env file. This should be consistent, and I'm just going to copy the private key just so I don't make any mistakes. We're going to say process.env.private key. But now we need to get those private key and the Mumbai RPC, and we're going to go in this vanity website that allows us to generate basically an account on this blockchain. And we're going to go down, click on generate. This is the public address of this account that we generated, and this is the private key. I'm going to click to reveal, then just copy this and paste it in the private key in the env file. Then we need to get the Mumbai RPC, which you can get here if you just go to this website, link in the description, and just copy this URL. I'm going to copy, then just paste here, save this .env file, and then to deploy our smart contracts, lastly, we will need to use this Polygon faucet, which is going to give us, I think, 2 Matic tokens. We're basically going to need tokens on this Polygon chain because we're going to deploy or change the state of the blockchain. And again, we're going to need the public address of this account so the faucet knows where to send those Matic tokens. Paste this here, click on submit, click on confirm, and then the request is submitted and tokens will be transferred. So we have done everything right so far. We have created the contracts here, we have provided the metadata, and we have deployed the metadata to IPFS, and then we've configured the network. So all we have to do now is deploy our smart contracts, and we're going to implement this deploy.js file that basically says how we're going to deploy the smart contracts. And for that, we're going to implement this main function that's called here, and we're going to delete everything above the main function. And to implement our main function, we're going to first require the ethers library, like so. Let's just say ethers, and then say require in Hardhat. So this is just one variable that we're getting from this Hardhat library. Then we will define this main function that's getting called here, and this is going to be async function. And let's just say function main. And then here what we need to do is first compile the smart contracts and get the compiled smart contracts. So let's say compiled smart contract, and this is going to be a constant. Let's call this Pokemons, say equal to, and we're going to use this ethers library and use its function get contract factory. And here we're going to provide the name of our smart contracts, which is Pokemons. And this is, we're going to have to wait this to happen, so just click await here. And then we're going to get our deployed smart contracts, or we're going to try to, now that we have compiled the smart contracts, we're going to deploy. So let's do Pokemons. We're going to reference this Pokemon's variable here. Then we're going to say just deploy. And here, if you didn't remember, let's go to the Pokemon smart contract. We have defined a constructor that takes in a name and a symbol for our collection. So that's what we need to provide here. Let's call this Pokemon's NFT Collection. This is the name, and the symbol would just be Poke. And then what we need to do is, actually this is an await function, and we're going to save this in this Pokemon's variable with small p, and we're going to await for this contract to be deployed. And how can we do that? We just use again the variable and say deployed, like so. And then we're going to console log this contract, and once this is done, the compiler will go here and will print out that this contract is deployed. And we're going to print out the address at which this contract was deployed, so we can later see it and verify it was deployed on the Polygon Scan Blockchain Explorer. So I'm going to just do Pokemons.address. That's the address it was deployed. And so since we have deployed the contract so far, what we can do is mint an NFT. And you can simply mint an NFT by just accessing the deployed contract and saying mint. And then here we need to pass the token URI, basically. That's what the main function, that's the argument that the main function requires us. And we're going to await this. We're going to add this later. Let me just first console log that we have successfully minted this. So NFT is minted. And I'm going to go into the JSON file and just copy this URL. This is basically the URI. Just save it here. Of course, pass it inside of string. And this content identifier changes, so we're going to delete this and go inside Pinata, refresh, and we're going to copy the new content identifier, paste it here, And now we're ready to deploy our smart contract. And the final step is to deploy our smart contract. We have implemented this file, but now to actually deploy it, you just do npms. I think you should do Hardhat and then run, and you should run this script. And the network is Mumbai, so press enter. And we've after the compilation finished successfully, we have deployed, compiled. This deployed script was run. We compiled the smart contract, we have deployed the smart contract, and then this was printed out, and then we got the address here. So I'll copy this address, and we're going to verify it was actually deployed to this Mumbai testnet by going into the Mumbai blockchain explorer and just pasting this here. And as you can see, we have deployed the smart contract and we have minted one NFT. For us to be able to verify or see our NFT on Opensea, we need to add the Mumbai testnet to our MetaMask, and we need to add our account that owns the NFT, which is this one. So go ahead and copy the private key, and we're going to add this account to MetaMask by going up here, clicking here, and click on import account. We're going to paste the private key here, click on import, and you're going to see that account 3 has this much matic. And now we need to add the testnet, which is called Mumbai, and you can add it manually by going into add networks, etc., or you can go into chain list and search for Mumbai, and this will show up. You need to connect your wallet and then just confirm the transaction, sign the transaction, and then click on add polygon, and after you do that, you have your polygon testnet here, and you can log in. And by the way, you should go to testnets.opensea because this is a testnet. Click on MetaMask,